So we've been talking about balanced graphs. Balanced graphs are graphs where all edges are either positive or negative, and every triangle is balanced. And we were wondering about what kind of global structure this local property implies. So let's review what balanced triangles mean. So there are two kinds of balanced triangles, either a small group of friends or ABC here, or two of ABC ganging up against the third. On the picture, A and C are ganging up against B. Unbalanced, in contrast, is either a pair of people, A and B here, who are enemies but have a shared friend C, which causes group tension and often resolves itself one way or another, either AB becoming friends or C choosing sides and going with A or B, or a triple of people, A, B, and C, who are all enemies, which gives the opportunity of two of the triple lining up against the third one. So a question we're asking that is thinking about large graphs where every triangle is balanced and wonder what kind of structure this implies. And we claim that the two kinds of structure we have seen so far is all there is. A large graph where every triangle is balanced either consists of a giant group of friends or is a polarized group with two groups are negative against each other, but friends within the group. So let's try to prove this. How would we go about proving it? So one option is all relations are positive, and indeed this is easy. If all relations are positive, we're facing a large group of friends and we're all set. If not all relations are positive, let's pick a person, let's say A, and the group divides into A's friends and A's enemies. So I indicated this with A's friends with black edges and A's enemies with red edges. So remember, what we want to prove is the group divides into two groups that are friends within the group, but enemies across the groups. And we see the group structure already just looking at A's friends. It must be the case, if indeed there are two groups, that one group consists of A's friends and the other group consists of A's enemies. So let's try to prove this. What I need to prove is that within X, all relations are positive. Within Y, all relations are positive. And across the groups, all relations are negative. So let's focus on X first. Indeed, in X, we see that A has positive relations. What we need to think about, is it true that other people in the group must have positive relations also? So let's focus on one of those. So A has two friends, B and D, in the group. And what kind of relation can B and D have? A, B, and D form a triangle, and if this triangle is balanced, and we claimed every triangle is balanced, it must be that B and D are friends, as there are only one kind of triangle with two positive edges that's balanced is the all-positive triangle. So now let's focus within Y. Within Y, so this would mean that A has two enemies, say E and F, and we're wondering what kind of relation E and F can have. And again, we see a triangle, A, E, and F, and we have to wonder about what kind of triangle this is. But there is only one balanced triangle with two negative edges, and that's the triangle in which A and E are friends. So again, it implies that within Y, the relations must be positive if all triangles are balanced. The final piece we have to do is wonder about all the edges between X and Y. And again, A has negative relations to every node in Y, but do A's friends necessarily also have negative relations? So again, we think about one of A's friends, let's say D, and one of A's enemies, let's say E, and we have to wonder about what's the relation between D and E. But as we have seen in the previous two cases, there's a triangle here, AD and E, a balanced triangle with a negative and positive edge. There's only one kind of balanced triangle like that, and indeed the third edge must also be negative. So what we have seen so far is that indeed, if every triangle is balanced, then either we're facing a large group of friends or we facing an antagonized group with, or polarized group, with one group of friends being pitted against another group of friends. What's interesting here is that there is a local property of three people's relations, how the triangles look like, and we claim the triangles are balanced. And it turns out it implies a global property in which the whole large network either looks like all friends or two groups being anonymous, being negative on each other.